Okay, so to answer this question, whether this 7.26 difference is a true difference or a sampling error, what we do here is we want to calculate the difference between these two test scores for each individual. Okay, so what we are going to do is to calculate the difference for the first person between his pre-test and post-test, and do the same thing for the second person, third person, all the way up to the 17th person. Okay. So here we can see the difference. The first person has a increase of 11.4 units, and second person has an increase of 11 points. Third person have 5.5 increase. Okay. So basically, we are creating a new data set called different scores by subtracting the before score from the after scores. Okay? And these different scores, they represent the anxiety difference for each individual. Okay? Presumably the effect or the result of our stats class. So let's say if this difference scores are equal to 0, ideally, okay? So ideally, let's say we get a result that the difference scores are equal to 0. So we can conclude that the stats class has no effect on people's anxiety levels, okay? But let's say if these different scores are significantly higher or lower than 0, we will conclude that this stats class do have an effect on people's anxiety level. It either increases people's anxiety level or it helps reduce people's anxiety levels. So after we are clear with regarding this point, we can set up our null hypothesis and also the alternative hypothesis for this new data set we just created. So our null hypothesis is this mu difference, which equals to mu after minus mu before. Okay, so we want to calculate this difference scores for all individuals, and our null hypothesis is that okay, there is no effect of our stats class, so we expect that this the mean for the difference for the 17 people will be 0. There is no effect. And the research hypothesis or the alternative hypothesis is that, of course, this difference, the mean for this difference scores is not equal to 0. And this brings us to the t-test Wessel familiar with. We're gonna particularly work on this new data set created by us, and then kind of apply all the same procedures with the t-test. Okay. So here is the different scores data set, and the mean is 7.26, standard deviation is 7.16. I'm gonna use this D represent the difference scores. So mu D represents the mean for the difference scores for these 17 people. Okay. First step, set up the null hypothesis and alternative hypothesis. Second, we're so familiar with it. We want to build a sampling distribution of the mean. Okay. Okay, so by population, this population, I'm talking about the difference scores population. Okay, and then we want to kind of do some calculation and work on the statistics for this sampling distribution of the mean. Okay. So for the mean for this sampling distribution, it will be equal with the population's mean, okay? Which is 0 because we assume there is no effect of this stats class, okay? And we expect no change between people's before and after test. So the difference score would be 0. And the standard error for this sampling distribution, okay? So we are gonna use this our samples SD to estimate this standard error. Okay. And we know the SD for this difference scores is 7.16. Okay. So we're gonna estimate the standard error using this samples SD. So our standard error would be our samples SD divided by the positive square root of our sample size. So we plug in the number, our samples SD is 7.16 over the square root of 17. 17 is our sample size, and this gives us the standard error being 1.74. Sorry. And this is how our sampling distribution looks like. So the mean of this sampling distribution would be equal to the population's mean, which is 0, because we assume there is no effect of test class. So the before test should be equal with the post test. There is no difference between these two tests. And our observed sample mean, which is 7.26, is somewhere here. Okay. And next step is we want to calculate the probability to get such a score as large as 7.26. Okay. And third step is we want to calculate the t-score for our observed sample mean. Okay. Exactly same thing with the t-test we did in last week's class. Okay. So the observed sample mean minus the population's mean. Okay. So our observed sample mean is 7.26 minus 0. 0 is the population's mean. And then divided by the standard error and give us a t-score of 4.18. And last step is we want to check the t-table for the critical t-value given the sample size of 17. So we have the degree of freedom being 16. And at the significance level of 0.05 with a two-tailed test setup. And we denote this t-value as t with the subscript of 0.025 because we want to divide this 0.05 by 2 because it's a two-tailed test. And then parentheses 16. 16 indicates the degree of freedom. And then we want to check this t-table. First, spot 16 as the degree of freedom, and then look at this column with two-tailed test at the significance level of 0.05. Okay, and then the critical t-value we have here is positive and negative 2.12. Okay. So our obtained t-value is 4.18, which is larger than this critical t-value here, given the significance level of 0.05. So we're going to reject this null hypothesis. And remember what is our null hypothesis? We assume that there is no effect of this test class on people's anxiety level. Okay, essentially, people would have exactly the same score between the post-test and the pre-test. Okay, so we're going to reject this null hypothesis. In other words, we can say that the after-test result is significantly higher than the before one. And get back to our example, we conclude that this test class does make students more anxious. Well, I feel sorry about this result for you guys, and I do hope that you guys can get more from my class, not just a pure anxiety. Okay, so that is this this example, this repeated t-test. I think it's pretty straightforward and very easy to understand if you have a clear understanding about the one sample t-test. Before we close this repeated t-test, I want you guys to do one more thing. I want you guys to calculate the confidence limits for our true population, right? So remember the confidence limits, the meaning of it is we want to establish an interval, a range that our true population's mean is likely to fall in, okay? So in our case, we want to calculate the lower and upper limits for our true population. So what is our true population? That is the people's anxiety difference between the before and after test. Okay, remember the general expression I showed you guys how to calculate this confidence limits. So this is the t-test here. So we know this our sample mean. We know this the standard error. We also know the t-score, the standard t-score. Okay, and we want to work out this mu score. Okay, so we do some algebra, and this confidence interval is some function of the sample mean plus the t-value. We have positive and negative t-value here, and then multiply by the standard error here. Okay, so remember t will vary as a function of the degree of freedom, which is basically our sample size. And then we're going to use 2.5% as a cutoff point on each tail, which is actually the 95% significance level, the conventional one. And if we want to go back and check this t table, we want to find out the critical t value here with a significance level of 0.05 and degree of freedom of 16. So we got the critical t value 2.12. So we're gonna plug in the numbers into this expression. Okay, so our sample mean is 7.26, and then this is a critical t value, and give us two numbers. And this 3.66 is a lower limit, and this 10.92 is the upper limit. So what does this mean? So these two values would set the limit of a range where our true population's mean, our population's true mean, is likely to fall in. So what is the population's true mean? Okay, so let's say right now we only have 17 people kind of being part of our experiment or research. What if we have a larger sample? Or what if we invite the whole population to participate in my study? And then what is the true mean? What is the true difference in terms of people's anxiety levels between the before test and the after test? Okay, so these two values give us a range where our population's true mean is likely to fall in. Okay, so how to report this confidence interval? We see that there is 0.95 chance that the true mean difference will fall into the range of 3.66 and 10.92. Okay, so note that this range does not include 0, which means that there is a true difference between the before test and the after test. Okay, after people take the stats class. Okay, there is the observed difference here is a true difference. It's not due to chance. It's not a sampling error. Okay, so that's all I have for this repeated t-test. And in next video, I'm gonna give you guys a practice, and that is your homework for next week's class. Okay, I'm gonna eat something. I'm so starving right now, and I hope you guys have a nice week and have fun at home and stay safe and healthy.